I'm from HP, Hewlett-Packard, but here I'm this evening representing myself. Ray asked me to come and speak to you about Hyper-V and Microsoft virtualization this evening. I guess I got this gig because Microsoft decided to make me an MVP in virtual machine. I'm not entirely sure why. I did some stuff last year during the beta of Hyper-V, and I did a lot of stuff with System Center Virtual Machine Manager, but it didn't seem enough for me, but they gave me my MVP. So this is like no other deck we've got on Hyper-V. I've assumed that you guys are all sort of developer types, and I was really glad to see earlier when the hands went up that you were. So I've tried to sort of pick off the stuff about Hyper-V that I'd want to know if I was what I consider a developer. So I've got about 30 minutes talking around Hyper-V, as I would to my own colleagues. I've got the smallest System Center Virtual Machine Manager deck in the world. It's about 3 slides. And then I want to flip into talking about using System Center Virtual Machine Manager and PowerShell and how they work together, because I thought that might be more interesting to you and end the evening with some code in front of your eyes. So some ground rules. I'm here representing myself, not HP. I don't work for Microsoft. I've got nothing to do with the Hyper-V development group. I don't own the feature set. You know, if you think it's a crock of shit, it's not my problem. Okay? All right? Okay. And, oh yeah, one other ground rule. I've been given a book to give away for the best question. The best question may not be the one that tests the presenter to his limits. Okay. So, just out of interest, how many people are running or have run Hyper-V? Okay, so that's sort of useful for me because I'm sorry about you guys. I could have gone into a lot more detail, but it seems the majority of the audience will take it from the ground up, which is where we're going to start. But we are going to move fairly fast to cover Hyper-V in 30 minutes. Okay, so what is it? So Hyper-V is Microsoft's 64-bit hypervisor. And let's take that slowly. So Virtual PC, Virtual Server 2005 R2 SP1 were both products that ran on top of an operating system. Hyper-V, being a hypervisor, is nearly the opposite of that. It runs underneath the operating system, and everything else runs on top of it. So that's very different. And we'll look at the architecture later on another slide, but it's fundamentally different in the architecture. It is directly comparable with Zen Server from Citrix or the Unix community, and it's comparable with ESX from VMware. There are some reasonable differences between the VMware architecture and the Zen Server and Hyper-V architectures, but it's comparable. It's a hypervisor. And it's 64-bit, which the Virtual Server 2005 wasn't. Hyper-V is included in quotes for free in Server 2008. So if you're on an MSDN or whatever, you can go and download it tomorrow. And there is a standalone version of Hyper-V Server, Microsoft Hyper-V Server, which is clearly based on Windows Server 2008. If you ever install it, it looks so familiar, but it's had all the Windows functionality stripped from it. So it's just a hypervisor. It's been around now for like 6 months. You know, there's already at least 3 major bug fixes to it. So, you know, you can start to feel safe running it now. It really is there. And it really has no functionality that's gone on from Virtual Server. It's written from the ground up. So don't expect it to be an evolution of Virtual Server 2005. It's a completely different animal. It's got very little technology in common. So what can you do with it? You can run 32-bit or 64-bit virtual machines, Windows or Linux. The supported machines are Windows and one particular set of Linux kernels. But in theory, you should be able to run anything that runs on an x86 motherboard. So you should be able to run DOS. You should be able to run, Windows NT and anything other horrible that you guys can think of. It's got in the product up to 4-way SMP for the virtual machines themselves. If you don't have a box that's got SMP in its hardware, then you won't get SNMP for the virtual machines. But if you're running on a quad core or something like that, then you can start to do 4-way SMP for your virtual machines, if that makes any sense for the workload that you're running. It's got high availability, got a slide on that later on, so you can have fault tolerance of some degree. The PXE client is talking about being able to boot the virtual machine, motherboard into PXE, so you can download across the network and build virtual machines using the same sort of build technology your organization uses today. So if it uses Windows Deployment Server, Altiris, or anything like that over the network, you can build virtual machines on Hyper-V using the PXE functionality. I'm really summarizing the product very fast here, but you're able to create virtual networks inside the operating system, both internal ones and external ones. So you can separate your virtual machines into different VLANs, keep them separate or join them up as you want, have private networks inside the machines so you don't see the external network at all. You can just do all that as you'd expect. And then if you're in a production environment, you might want to use VLAN tagging, so it goes straight out onto the routers and is already segregated and goes off on the right VLANs. In terms of the disk subsystem, this is the one thing that is common probably in terms of Virtual Server 2005, in that it uses potentially the VHD disk format. So in Virtual PC from Microsoft and Virtual Server 2005, you could store the data disks and the operating system disks of the VMs in .vhd files. And you can use exactly the same disks in Virtual Server 2005. So in theory, you could just pick up your Virtual Server 2005 machines, put them into a Hyper-V environment, build a VM and boot them. Okay, there's some caveats around that, and probably talk to those after the presentation, but it would work. But there's also the concept of pass-through disks. So you can get a LUN or a spare physical disk and present it directly to a VM. So it's actually directly writing to the physical hardware rather than writing into a file. And that has a performance gain if you want to use that kind of technology. Now typically down at the low end, where we're developing and just playing around as IT pros and doing stuff, we typically wouldn't use pass-through disks, but I'm just giving you the full feature set. Okay, what's not in the box? This is a good way to do it. So the big things are there's no memory management in the way that Xen Server and ESX do things like balloon drivers and overcommit. So what that means is if you've got a VM or a couple of VMs that are going to take 512 meg each, you are going to allocate a gig of RAM on your Hyper-V box. So just to make it simple for you, I've got a machine here that's got 4 gig in. If I've got 4 1 gigabyte VMs, they aren't all going to run because the operating system itself, the parent partition itself takes some of that RAM. So you just can't, consume all the RAM, and you can't overcommit like you can, in ESX and just squeeze more machines on. So you've got to be a bit careful there. Hot add CPUs and RAM. It's not in the product. It's not a big deal to me. I don't often, in my virtual environment, want to add CPUs or RAM. What kills me is I can't add disks to running virtual machines with Hyper-V. That just seems to make a lot of logical sense. In a SAN environment, I can just pop up LUNs, consume them into my running machines. So why can't I do that in a virtual environment? So that's missing from Hyper-V today. And then the one that everybody who's a big VMware fan goes on about is Live Motion. So Live Motion in VMware allows you to move a virtual machine from one physical host to another with no downtime at all, without skipping a heartbeat while that machine's running. Hyper-V does not have that functionality. It has something called quick migration, which again, I've got a couple of slides on. Does anybody think I've missed anything big who knows Hyper-V? Okay. So a lot of things, something's gone wrong with the slide, but anyway. So a lot of things to speak about on this slide. Hyper-V, I've said, is in Windows Server 2008, and it's in 3 of the 5 SKUs. So you don't get Hyper-V when you buy Web Server or the Windows version for Itanium servers. So it's really, we're talking about standard enterprise and data center editions. Now, the interesting thing is really that you can run, if you just got a box like a laptop or a small server, you can just run Windows Server 2008 Standard Edition, put in the Hyper-V role, and you're good to go. If you want to go above 4 processors or 32 gigabytes of memory, then you're going to need to move up to the enterprise or the data center SKUs.
Is it processors or cores?
I believe it's processors, but I could be wrong. Yeah? Okay. Because I think that's an operating system limit, not a Hyper-V limit. Okay. So that's easy to check. The reason you'd want to go to enterprise or data center, there's 2 reasons. One, that with both enterprise and data center, you get the ability to do high availability with Windows Server 2008 and Hyper-V using clustering. And obviously there's more processors and more memory. But the other thing is also licensing. So on the right-hand column is the most misunderstood feature of Hyper-V probably, which is if you buy Standard Edition, Microsoft give you an extra license free to run a Windows Server operating system. So you get 1 license. But what that doesn't mean is you can only run 1 virtual machine on Standard Edition. You can run as many virtual machines as you want on Standard Edition, as you got RAM for. You just need to go and buy your own licenses, yeah, for Windows, or if you're using Unix, you have your own Unix licenses. So there's no difference there. And with Enterprise, you get 4, and with Data Center, you get unlimited virtualization rights. So the point here is if your organization is going to use lots of virtual machines, they just might go to Data Center, which you can now just buy just for the licensing model alone. And that is based on per processor. So you'd have to look at that. But there are some interesting calculators on the web. The last part of this table, which is interesting, is this standalone version of Hyper-V, Microsoft Hyper-V Server, which is an absolutely bare metal cut down version of Windows Server Core, which has no GUI, none of the application programming interfaces, and has its own little config utility. And if you just want to put up Hyper-V and you don't want to bother with Windows, it's a nice little tool. Just installs off the ISO, very quick install, little configuration GUI, and you're good to go. So if any of you have worked with Server Core in Windows Server 2008 and been frightened of having to configure your box from the command line, then trust me, if you go into Microsoft Hyper-V Server 2008, the nice little utility there will get you going straight away. So it's a lot more usable than Server Core. So I think I've covered that one off. Requirements, things that catch people out. The big requirements are you've got a 64-bit hardware, and it's got to have what they term hardware-assisted virtualization. So Intel and AMD have got their own technologies that the hypervisors use to do the virtualization, but it has to be on the chip. DEP has to be on the chip as well, data exclusion protection. That's fine. The killer that some of my friends have found is they've had hardware with the right chipsets in, but the BIOS from the manufacturer has not supported the fact that you wanted to turn on the HAV feature on the processor. Okay, so, and I find it really hard. I mean, I work for HP, but I can't find the spec of the desktop machines that do have HAV-enabled processors that have it enabled in the BIOS. You sort of, either find it or you have to trust it, or you find a machine that works and go and buy a few of them, because then you know it's in the BIOS. So it has to be supported. So if you want support for Hyper-V, you need to run on Windows logoed hardware. In reality, as you've seen tonight, the gentleman before me was running on an IBM notebook. I'm running on a HP notebook. I'm running Hyper-V as we speak. This presentation is given from a Hyper-V machine. It works generally on Windows logoed hardware quite nicely. So that's not a problem. And then just the last thing to remember is when you spec your machine, you want enough RAM to run your VMs and the host operating system itself. So I thought I'd throw in an architecture slide. I could speak for at least half an hour on this slide, but I won't. I haven't got time. What I'm trying to show here, or what the slide is trying to show, and this is the Microsoft standard slide, is that you've got the Windows logo hardware at the bottom. You've now got the very thin hypervisor directly running on the hardware, responsible for CPU scheduling and memory allocation, generally. That's its purpose. And all the other clever stuff in Hyper-V, unlike ESX, is done on the left-hand side in the parent partition. So this is a privileged VM that the hypervisor gives special rights and functionality to, that is responsible for all the management of the Hyper-V environment. Okay, so things like creating new VMs and so on is all done out of there, talk to the hypervisor puts them up, but the logic is running in a Windows Server 2008 virtual machine, which is privileged to the hypervisor. The other thing you'll notice is there's this thing called the VM bus, which seems to join up these vertical, what are meant to be virtual machines. And this brings us to one of the features you probably need to know about Hyper-V. What happens now when you run a virtual machine is it can either run in an enlightened fashion, where it's got what we used to call VM additions, but are now called integration components, which make the operating system aware that it's running in a Hyper-V environment and optimized for the Hyper-V environment. So if you've got the integration components in your Windows operating system or your Unix operating system, then what you'll have is drivers that know how to speak to Hyper-V across the VM bus to the parent partition. And all the I/O is then done very simply by just collecting the information and passing it along the VM bus. The hypervisor doesn't have to emulate a network card or emulate a disk card or video driver. And that emulation is what's normally cost virtualization products in the past all their performance. So by using the integration components, the information just gets shoved across the VM bus very quickly, processed by the Windows logo device drivers in the parent partition, and the I/O just happens. It's very cheap to do I/O across the VM bus. So the last part of the picture is over here we have a non-enlightened operating system. So this could just be a machine that you've P2V'd and not enlightened at the time. It could be an operating system that doesn't have enlightenments. It still runs happily on Hyper-V, except the hypervisor now is doing emulation of all the hardware that it's speaking to do the I/O. That burns hardware cycles in the hypervisor and slows down the I/O through this machine. So ideally, you will put the integration components into your VMs. And that's probably really all I've got time to speak about on that slide. One screenshot of what Hyper-V looks like. This is actually the Hyper-V server, the standalone product. So what you're seeing here is effectively Windows Server 2008 Server Core, and that's the black window at the back, just the command window. Server Core has no GUI, no APIs for applications or anything. But they've now added in a second window which runs the configurator for Server Core, basically, and allows you just very quickly put in the machine name, put in the IP address and so on, without having to remember or know all the command lines to do that. So it's very quick to configure this up if you just want to put up a Hyper-V box. And that's it. It's so exciting, it's true. You'll never, once you get it into your management environment, because you have to manage the VMs from outside of Microsoft Hyper-V Server, then you'll never probably look at the GUI again, because you just manage it on the outside and put your VMs up and so on. So this slide is about two things. One, it's about the supported operating systems on Hyper-V. So these are the operating systems that you can go back to Microsoft and say, I'm having problems when they run on Hyper-V. And you'll see in the right-hand column that they're supported with a variety of processors. So basically only Windows Server 2008 is supported with 4 procs, all the way down to Windows XP Professional SP2, which is only supported on a one-way. That's just their test matrix. The other side of this slide is that, what was I going to say, the integration components that you can get to speed up the performance of the operating system on Hyper-V exist for these versions of Windows. So you notice there's no NT4 here, so there is no NT4 integration components. If you just put up Windows Server 2003, you need to rev it to SP2 before the integration components will install. I'm hoping there'll be more Linuxes in the future, but that's up to Microsoft, I guess. So I talked about high availability with Hyper-V, Basically, the way it works is you put up a Windows Server 2008 cluster, and you run Hyper-V on the nodes in that cluster, and the virtual machines just become a cluster resource in the same way that printing or file serving is a cluster resource in Windows. And if the host running those VMs fails, the cluster manager will attempt to restart them on another cluster node. So depending on your experience with Windows clustering, you now may feel a big piece of dread in your heart. Clustering has never been simple in Windows. It is significantly simpler in Windows Server 2008. They've done a lot of work. You don't have to have specialist hardware anymore. You can have Windows logoed hardware. There's a special configuration checker in Windows Server 2008 that just says, yes, this hardware is certified to run a cluster on or not. It runs every time you change the hardware. So that helps. And the whole point about Hyper-V clusters are they're there for two things. One is planned downtime, where you've got a VM that's running and you just want to move it across to another node in the cluster so you can do some maintenance work on that node. And this is where quick migration comes in. Basically, it pauses that VM, writes out the memory state to the drive, flips the drive over to another node in the cluster, and that cluster node then pulls the memory in and the VM starts running again. And I've got a slide after this to tell you how quick that might be. The other point to that is for unplanned downtime, if your host crashes, then clustering will just try and restart those VMs on other machines in the cluster, as long as they're on shared storage, and bring them up. So it's just like the hardware's crashed, they have to reboot, but the service should become available again. You'll have lost everything in memory, but that's just the same as a physical server crashing, except you'll have more of them crashing at the same time. Well, that's virtualization for you. Yeah. So the last thing about clustering is we now got 16 nodes potentially in a Windows Server 2008 64-bit cluster, which is what you'll be using. The point is you have to leave enough headroom, i.e. spare RAM, in some other nodes for it to start the virtual machines that you want to fail over. And if you were big into ESX and Virtual Center, then you would quickly work out that Microsoft is not so clever because you can't prioritize and shut machines down and so on. It really is clustering at its basic. So this slide is just Microsoft's numbers for how quickly you can move a VM on the left-hand side of a particular memory size with a particular shared disk connection speed from one machine to another. These are their numbers. We're not sure those numbers are correct. One of my colleagues has got a lot of hardware and he's tried it himself and he gets different numbers to that, so your mileage may vary. So whether quick migration works for you will depend on how your application or the consumers of your application can cope with it being paused. You know, do you get IP timeouts? You know, does your application time out in itself and so on? Yeah, it's not like live migration where the machine continues to run with ESX. Okay, I thought I'd throw this in because it brings up some other points. So best practice with Hyper-V. The best practice in production is to use a variant of Windows called Windows Server Core. And I've spoken about it already, but let's gauge this. How many of you know what Server Core is in Windows Server 2008? Okay, third of the room. So for those that you don't, this is the time to be frightened. Okay, so Server Core in Windows Server 2008 is a version of Windows that does not have a GUI shell. The only interface you have to it is cmd.exe. There are some GUI bits that work. All the application stuff has been stripped out, and the whole purpose of Server Core is just to run infrastructure roles like DHCP, Active Directory, and so on. It's really stripped out. And the idea is that it's hardened by default, so you don't have to do a lot of hardening to it. You don't have to harden services that are not there. Okay, the code, you know, you don't have to harden APIs that are not there. They've just been stripped out. The minimum is in Server Core. So the idea is there's just less moving parts. It's more reliable, significantly harder to attack. You don't have to patch it so often because, you know, if somebody comes out with a patch to IE Explorer on Windows Server 2008, well, it doesn't apply to Server Core because the code is not in there. So you run Server Core because it's going to be more reliable, because I guess what I failed to point out on the architecture slide is if you lose the parent partition in a Hyper-V system, you have lost the VMs. The whole system goes down the tubes because all the I/O is going through it and so on, and all the management's going through it. So we need that parent partition to be as reliable as possible. So your organisation will want to run management agents and MOM or antivirus in that partition. It won't be able to resist the temptation to put stuff in it. But you don't want to be running any application code in there for two reasons. One, you want to make that partition as reliable as possible. But two, the parent partition runs with a slightly elevated priority relatively and special privileges, and it could actually reduce the performance of the actual production virtual machines that are running on the Hyper-V box. So don't run any application code in the parent partition. Then with the network interfaces, the recommendation is you're going to need at least two. You're going to need one for management of the box. You're going to need another one for the virtual machines to use to get to the outside network. And then if you're using, say, iSCSI on your machine, you'll want another NIC just for your iSCSI for all your data transfers to go over. So typically, when we configure up a virtual machine environment for production environment, we end up with lots of NICs. If you've got 128 virtual machines, as we are in the VDI environment, running on a Hyper-V box, you just want a lot of network connectivity, and you want to spread your machines over all those NICs. And then the last thing is, I've already said you've got to assume 512 megs of RAM for the parent partition, because it is a Windows OS. But there is actually a formula in the 2008 Performance Tuning Guide which tells you if you've got this many VMs with this much amount of RAM, this is how much space you should leave for the parent partition. But you never get below 512. Okay, so you can go and look at that. So just going to sort of start to summarize now. So you might be sitting there saying, well, I'm running ESX today, I'm running VMware Workstation, I love it, it works for me, why would I run Hyper-V? And as I say, I'm not trying to sell it to you. The reasons that we come across is, firstly, because your hardware doesn't support ESX. There aren't drivers for it for some reason. You need real servers to run ESX generally, and the sort of lower class machines, maybe the desktops that you get in your development and test environments, won't run ESX. So Hyper-V's there, it will run on a Windows logo box. The other reason is, if you are a Windows person through and through, why do you want to run an operating system like XenServer or hypervisor like XenServer or ESX that when things start to go wrong, you have to do Unix? Not you have to do Unix, you have to do tricky Unix because it's now going wrong, okay? Me, personally, that frightens the hell out of me. I'd much rather have it going wrong in Windows, which is a world I know and understand and I can live with. But interestingly, in the big customers that we deal with, they don't have a problem with running a Unix-based hypervisor because they've got big Unix shops. They just get the Unix shops to run ESX and let the Windows VMs run on it, but get the Unix boys to run ESX or XenServer because they understand Unix. It's a good model for them. But not everybody is that way. And then cost. Well, I've hinted already that Hyper-V is free. It's a rolling Windows Server 2008. The standalone Microsoft Hyper-V server is just downloadable from the web. You can just download it, make an ISO, install it. It's free, and it's got no licensing restrictions. But actually, it's all about the management environment. So you may just find that by the time you actually build a proper management environment and license everything, that the cost of Hyper-V is minimal. It's all the other stuff you put in your virtualization environment that costs money. So you have to cost it that way. But if you're a developer like me, you've got MSDN, you just go and use it tomorrow. It's no problem. So 3 slides on things I haven't spoken about or have spoken about, but 10 things I thought I ought to tell you. And they're in no particular order. So don't think that the order is important. They're just as they came to mind. So one of the killer things about Hyper-V is NIC teaming is not supported. So if you're not a server guy, what that means is in the server world, we typically take 2 NICs in a server and we use some kind of teaming software that makes them one. And so they'll become a virtual NIC. And if any of the NIC fails or the connection to the network or so on fails, then that NIC just carries on working and the data goes in and out of the machine. Now, the interesting thing is that we've suddenly realized is Microsoft does not support NIC teaming. NIC teaming is written by the hardware vendors. And the hardware vendor, in this case that I work for, HP, does not support NIC teaming with Hyper-V. Interestingly, it works, but for some reason our people won't support it. And the story I've got is there's something deep and horrible in the drivers that they do not like. And we could actually at this point have a slanging match between Microsoft and the hardware vendor about it's your fault or it's not. But actually they're being grown-up boys. I know they're working on it, and we will see NIC teaming, I am sure, in some kind in a future version of Hyper-V. But that's only my view from the outside. But there is definitely a known problem here. The other things I haven't spoken to, number 4, is one of the things that I think will catch people out, but Microsoft never tell you, is if you use Hyper-V, which is a Windows Server 2000, if you use Windows Server 2008 Hyper-V, so you install Windows Server and enable the role, then you need a Windows Server 2008 CAL for any device or user that accesses the VMs running on that hypervisor. So let me take an example. You just want to play with Hyper-V, you put it in your data center, you get it running, and you think, why don't I go and put my Windows Server 2003 DHCP server on this Hyper-V box and see how it works? Okay, the moment you do that, every device that gets a DHCP address should have a Windows Server 2008 CAL. I think that's a big deal. Microsoft say it's not in general because they say all our customers have got EA or SA agreements and whatever. You can make your own judgment. You know how your licensing works in your organization. But that's the way it works. If you run the standalone product, Microsoft Hyper-V Server, that restriction goes away. But you don't get high availability and you can't run it on your biggest boxes. Number 5 is not a big deal, but it's something that kills me. There's 2 types of NIC that you can put in a virtual machine in Hyper-V. One's called a legacy NIC. It's emulated by the hypervisor and it allows you to PXE boot, but it's obviously slower because it's emulated. And then there's a synthetic NIC, which is only available when an operating system with the integration components loads. And so many times have I found myself trying to boot off the network a VM that's got a synthetic NIC. It kills me every time, and it's just the way the GUI works, and I'm just warning you, you'll come across it. The last really big thing is if you install Windows Server 2008 today from the media and you enable the Hyper-V role, you have a beta version of Hyper-V. So when they shipped Windows Server 2008, they chose, ill-advisedly if you ask me, to put a beta version of Hyper-V in. So what you need to do is you need to install Windows Server 2008 and then go and get this patch, KB95050, and install that on your Windows 2008 server, and then you've got the RTM bits, the final bits of Hyper-V. And if you want my advice, if you're going to build a Hyper-V server, you install Windows, you put the patch on, then you enable the Hyper-V role. And it'll just behave better when you configure it that way. You won't get into some of the beta bugs before you put the final code on. Yeah, there's some other patches if you want to use System Center Virtual Machine Manager, which you should be aware of. And then the last one, and it's a sort of a negative to me, that if you're used to using things like Virtual PC or VMware Workstation, you have nice integration features between your workstation that you're working on and the virtual machines, and you're able to share drives and so on, and very easily trade back that sort of information. That is not in Hyper-V. Hyper-V is aimed at the data center, server environment, relatively high security, and you don't have any of those nice integration features. So in terms of personal use, if you've got a VMware Workstation today and you're happy with it, you probably want to stay with it if you use these integration features. So that was my 30-minute Hyper-V presentation. What I'm now going to talk about is System Center Virtual Machine Manager and some PowerShell stuff. So in 3 slides, System Center Virtual Machine Manager is Microsoft's product for managing the hypervisor environment. So if you've just got one box running Hyper-V, then fine. Go and use the MMC GUI that's in Hyper-V to manage your virtual machines. But if you start to have more than one box, or you really want to be able to just automatically provision machines, churn out lots of machines to do tests on and so on, then you might want to start looking at System Center Virtual Machine Manager. It's there to manage, I think, 300 hosts, thousands of VMs. It supports Virtual Server 2005, Hyper-V, and ESX. So that's sort of useful. It'd be interesting to know how many people use that side of it. And it's there to do both operational management, so you can start and stop your VMs, see what state they're in, change them, change the host settings, and so on. And also to do provisioning and deployment. And because, like all the System Center products, it's based on PowerShell, which I'll come to in a minute, you can automate up the creation of machines and so on using PowerShell. So it has P2V, which means you can go and get an existing physical box and move it into your virtual environment automatically, or you can go out and get an ESX VM and move it into the Hyper-V environment through System Center Virtual Machine Manager. So it's a multi-purpose tool, really. And then the final part, which may interest you guys, is it's got a self-provisioning portal. So you can put up System Center Virtual Machine Manager, enable the provisioning portal, and give your developers or yourself access to just go into a web interface and just say, I need machines of these kind of templates, just create them for me and let me manage them through a web interface, not having to come into the self-service portal. It does take a little bit of setting up, but it's there if you're not going to go to this fantastic new test manager in Visual Studio 10. So this is my architectural diagram of System Center Virtual Machine Manager. What I've basically got here is you need one machine running Windows Server 2008 that runs VMM itself. That talks to SQL on the back end, either SQL Express or a fully fledged SQL database to store its configuration information and so on. You talk to System Center Virtual Machine Manager through either PowerShell, the self-service portal, which uses PowerShell at the back end, or the admin console, the GUI, that uses PowerShell at the back end. So that, like, my user at the top there is using both. I've got a user out here with his own machine talking to admin console or PowerShell that he can install, and that goes to System Center Virtual Machine Manager. Now the point is, if you want to manage these hypervisors over here, you don't use PowerShell, for example, to speak directly to them. What you use, you talk to System Center Virtual Machine Manager, it talks to the System Center Virtual Machine Manager agents that's running either on Virtual Server, Hyper-V, or in the ESX environment on Virtual Center, and then it goes and talks to the hypervisors to do whatever you need to do with those VMs. And I found this architecture really helped when you start programming in PowerShell. It gives you an idea of what you're talking to, and basically you're always talking to VMM, and it does everything for you. You don't need to be able to speak to the hosts. So this is its GUI. There's a lot going on here. We could talk all night about it. It builds. I stole this from Microsoft. So on the left-hand side, you can divide all your millions of hosts into different groups to manage them depending on how they're arranged. This is a nice filtering pane. So depending on whether you're looking at VMs, hosts, or jobs, or the library, you can very quickly choose what you want to see through that little filter box. Delegated control, I don't think that's really showing it. So the centralized library is about having virtual machine templates or hardware profiles configurations that you can combine to create the type of machines that you want. So you can put sysprep information in there and so on, and just have the machines build automatically for you from a library. If you click on a virtual machine in this environment, so we're looking at this one here, you get a little thumbnail of actually what's going on the display at the time, so you can get a quick view without having to pull up a console. And on the right-hand side, you get these context-sensitive actions. And basically, once you get used to working in VMM, I turn this off because I actually want the information in the central window, which is really what I'm looking at, the full width of the screen, and I know I can right mouse click and do what I want to the machines or the jobs and so on. So, moving quickly on to some code now. I guess my first question is, who knows about PowerShell? Is it only that few, genuinely? Oh God, this is scary. So I was hoping to go on to the next question, which was who can write scripts in PowerShell? One. Well, my mum, okay, 5 or 6. Who would write PowerShell scripts by default? 2 of us then. Right, okay. So I'm going to take this slowly. So if you've not come across PowerShell and maybe you don't need to write scripts because you're hard developers, then I understand that. But as a system administrator, you know, batch files in cmd.exe don't hack it for me. And Microsoft have put together PowerShell, which is, you know, it's all the things you know about Unix shells, it's all the things you know about VMS, some of the IBM shells, it does pipelining. It really has got all that power. And then for you guys, it also uses objects, which is not something I've seen in a shell before. And, you know, for me, I can do everything with objects that you guys can do, you know, with C++ and so on. So it makes my life very easily. You know, it's got none of this horrible type checking or stuff like that. You know, it just sorts the mess out for me. It really is a script. And, you know, one of my favorite quotes is when people, you know, make out something that's hard, I just say I can do that in one line of PowerShell. And that is very often true. So, you can see PowerShell today, you know, it's a scripting language you can install in 2003 or 2008. It comes in the box. You know, System Center products are now built on it. And it's just being picked up by all the vendors as well. And what we'll see in Windows 7 is a lot more PowerShell management of the operating system itself. So, you know, it's not V1 and it's going to die. We are seeing Microsoft adopting it. So if you're going to script and you want your life to be easy, you might want to start looking at it. I've lost my titles. What I wanted to show you in the next few slides is if some of you were going to go home and start using System Center Virtual Machine Manager and you wanted to start automating those actions, you know, you want to go home and create 100 VMs for some test reason, and that's sort of something I might do. I'm testing deployments, automated deployments, for example. It's really easy to do it with PowerShell and System Center Virtual Machine Manager. But when I started down this road, I found there are about 4 fundamental things that I just did not get. And I wanted to show you them tonight and share them with you. So if you start down this road of using PowerShell and System Center Virtual Machine Manager, it starts to make sense for you. So the first one, and it's nearly a default, is all the PowerShell commandlets for System Center Virtual Machine Manager are just really long. So you get things like get-virtual network, you know, or get-virtual DVD drive. I do not have enough life to type that stuff, right? Okay. And the great thing is in PowerShell, you've got tab completion, like you have clearly got in the Visual Studio's editors. So you type get v tab, that's not what I want, tab, whoops, missed it, shift tab, you know, and very quickly I've got that long command line built up. Okay, so that's just there. The other thing is that when you want to start using System Center Virtual Machine Manager commandlets, you have to make sure the snap-in for System Center Virtual Machine Manager is in your PowerShell interface. And there's 2 ways to do this. The way the product group like you to do it is to go to Virtual Machine Manager 2008 folder in the Start menu and start PowerShell through there. If you're a hard PowerShell person like me and you start a PowerShell window, then you need to do this add ps snap-in command the first thing you do. And clearly what you do is you just put that in your profile for PowerShell and it gets done every time and everybody lives happily ever after. So after you've got over that hurdle, you might want to just see what System Center Virtual Machine Manager adds to the PowerShell environment. And it's very simple, get command -ps snap-in, and it'll just list off all the new commandlets that snap-in adds. And then you can start getting excited because there's things like set VM and, you know, so stuff like that. So great. So you're just about to write your first PowerShell script. We'll just start to play around with it in the interface. And the thing that will next fall over is you have to have a connection to a System Center Virtual Machine Manager box. Even if you open your PowerShell window on the machine running System Center Virtual Machine Manager, you don't have a connection. So you need this get VMM server minus computer name localhost, or you can point it at one across the network. Again, it's just really trivial, but you'll trip over it the first time you try and do this stuff. So the next thing is object references, and I'm going to take a few slides to explain this. And this kills me, and I'll be very interested if you guys, with your developer background, just go to me, no, Jeremy, that makes perfectly sense to us because we work in objects all the time. But for me, right, if I'm working in PowerShell by the default shell, and I want to look at a file, the PowerShell command is getChildItem. You can type dir or ls, those aliases are in there, and you might type the file name. That just makes perfect sense to me. The command, what I want to operate on as a string. If I want to work on a process, get process outlook. That just sort of makes perfect sense to me. So if I was going to look at the library in System Center Virtual Machine Manager, it would make sense to me to do something like refresh library share and then the library share name. That just makes sense. That's what it's called. Just go and do it. But that does not work in PowerShell. It's just a typical example with System Center Virtual Machine Manager. What they want you to do is you have to go and fetch the object, and when you've got the object, the Virtual Machine Manager object, you give it back to PowerShell to go and operate on. So you get into this really horrible syntax where you have to do get library share all, so you get all the library shares that VMM knows about. You then pipe them into a where statement where you filter out the one that you want or the ones that you want, and you store them in a variable $object share. And so in PowerShell, anything beginning with dollar is a variable. And then you can do refresh library share and give it the virtual machine object to go and refresh. Now, I just find that really clumsy. What do you guys think? Yes? No?
It's clumsy from a UI point of view, but it does make sense from a framework point of view.
Okay, fine.
There's nothing to stop you writing your own library shares. It doesn't help for you, is it?
Yeah, okay, which is sort of where I get to on the next line. And again, this is typical. What you end up doing is not putting in an intermediate object, but you do get library share all, you pipe it through the where, and then the object's going to come out of that pipeline. So you put it in another pipeline where it just goes into the refresh library share. Yeah, and once you get used to just thinking about that, get all the objects, find the ones I want, throw them into the command I want, you're good to go. So here's some typical ones. Get VM where the status equals running, save the VM. So there you are in a VDI environment with 10,000 virtual machines running, and you've got System Center running it all. You do that, and you will pause all 10,000 VMs. It'll take a while, but it has a real impact, so be careful. Yeah, I mean, just three different examples of the same thing, really. So the last thing that I want to get over in terms of writing System Center Virtual Machine Manager is the concept of a job. And this really did my head in for a long time. So I want to create a VM. That's like a very basic thing to do. So surely I create the VM, I add a hard drive to it, I add a NIC to it, I add a DVD drive. No, that's the way you do it in the GUI. But the way you have to do it through PowerShell and System Center Virtual Machine Manager is you use a job. And you create a grid to define the job. You then use the PowerShell commands to create the virtual network adapter, create the DVD drive, and add the virtual hard disk, and associate them with the job ID. So these things are now like in the mind of PowerShell. I sort of have them out there, they're associated with the job, and then you finally come along with the new VM command, give it the job ID, it collects up these components of the virtual machine you're trying to create, and you finally go away and create your VM. So that has a lot of goodness in that jobs are tracked by System Center Virtual Machine Manager. If it fails for some reason, you can go and fix a fault and restart the job, and you don't have to write the code to manage all that backing out and restarting. But as I say, it just all seems the wrong way around to me. And that's an example of doing it with new job. There are other ways of doing grouped commands, job group commands in VMM. The thing that's hardest to work out is there is always one commandlet, and in this case it's new VM, that triggers the job. If you were to do it in a different order, if you were to put your add virtual disk after this point, it doesn't get added. This has to be the last commandlet. And that is just not always obvious to me, and I'm just trying to bring that up to you guys so when you get into this, you know I've said it. So I've got 3 more slides now, which I'm actually going to skip over, but if you pull the deck and you're interested in this stuff, there's just more examples of the sort of basic PowerShell you can write on the command line with System Center Virtual Machine Manager. So just wanted to end with this. I've spoken about PowerShell for managing System Center Virtual Machine Manager environments. You can also use PowerShell to manage Hyper-V directly using the WMI class Virtual System Management Service. It's nowhere near as friendly as doing it in System Center Virtual Machine Manager, but it's there to be done. And there's a good blog by one of my colleagues, Dong Hong Kak, about how to use the PowerShell and WMI to manage Hyper-V. And also, if you're not using Hyper-V, but you're using XenServer or you're using ESX, both those vendors have made PowerShell commandlets for those environments too. So, really, there's no excuse not to be using PowerShell to start managing your environments and automating stuff you do. So that's pretty much me. Gave you a real quick run through Hyper-V, an even faster run through System Center Virtual Machine Manager, and I probably wasted my time trying to tell you guys about PowerShell and how exciting it is with VMM. So I've got about 10 minutes for questions if you want them. No one's asked me any questions, so this book's going home with me at the moment.
This does a brilliant question, but the licensing.
Yeah.
You showed that the number of client licenses. Is that running at any one time, client licenses? Like, might have 200 VMs developed.
Yeah.
You've only got 4 at once.
Okay, what I should do is refuse to answer this question because Microsoft licensing is such a minefield.
Well, no, well,
Yeah.
I mean, it wouldn't make sense otherwise, really, would it?
So the virtualization licensing has changed, and I think it is running machines. Yeah, and you can have as many machines built as you want, but it's only the ones that you're running. Yeah, but you have to be very careful when you start moving machines around because they have to be assigned to a certain machine and so on. Yeah, it is definitely a nightmare. But I have seen big companies save a lot of money by starting to use data center. Right, so they're buying a physical box, they're buying the data center license with Windows Server 2008, which gives them unlimited virtualization rights, and then they're using ESX as a hypervisor, right? Because it's per box, and that's just a really good way of buying Windows. Yeah.
Just something to know on the data center one is per physical processor.
Yeah.
So as the number of cores go up, it becomes even better value.
Mm-hmm.
So if you're buying the data center license, squeeze as many cores on as you can.
Yeah.
You'll get more use out.
That'd be a good way to choose your hardware, isn't it? Is less processors, more cores. Yeah.
Very stupid question, but what does SMP stand for?
So SMP is symmetric multiprocessing. So it allows more than one thread in your code to be running simultaneously. Okay.
The migration of virtual machines, is it particularly fussy about the underlying hardware? Could you migrate or quick migrate from, say, an Intel machine to an AMD base?
No, I don't think you can. Because if you think about it, it's saving the memory state. Yeah, and when it restores that memory state, then if it's on a different processor hardware, how the hell is that going to work? And that's the same with VMware as well. With ESX, there is a definite matrix of what processors you can have to swap between. Now, I understand they might move that, but right now I see so much traffic inside HP arguing about how you can do live motion between different kind of processors, and there's a matrix. No? I have definitely seen correspondence about that, and you just can't have the different processors. And in Hyper-V today, that's definitely true. Yeah, I'm hoping the cluster checker would fail at that point.
How good are the ESX management tools in at the moment?
For managing ESX?
Yeah.
That's a sort of unfair question because Virtual Center is not equivalent to VMM, but then you get tools from VMware, like Lab Manager, which are way beyond VM. So it depends what components you want to pay for. Yeah, and there's a good argument that if all the hypervisors have the same performance, then, or even if they don't, it's all about the management tools anyway, and that just depends what you're trying to manage. Yeah. So any more?
As a developer, what kind of integration we have with PowerShell in terms of calling it from programming languages.
So as a developer, what integration do you have with PowerShell?
I want to do a kind of like, if I want to zip up one set of files or do some operation on a set of servers, that to be moved from a C# program, for example.
That is definitely possible. You call the PowerShell XC and you put your command in, and you're sort of going beyond my knowledge now, but I know people are doing that. You know, they've got stuff underlying in PowerShell that you never see, but they are using PowerShell to go and do it. Yeah. So, for instance, you know, the System Center Virtual Machine Manager GUI or the web front end is calling PowerShell to do that sort of stuff, and some parts in the GUI will show you what it's doing. It will give you the PowerShell, which is your starting point for automating it. Yeah. But you know, you can use PowerShell today to do the sort of scripty things that you would do rather than write lots of code for. Yeah. So I'll take this one.
Just as a matter of time, we need to wrap up now.
Okay.
Maybe choose your best question.
Okay, I'll take my last question then. Sorry, it was there. Yeah. Sorry, you beat you to it.
I've got one question about the clustering and the failover.
Mm-hmm.
If you've got, say, all your VMs as VHD stored on the LUN on the SAN, can you say failover individual VMs, or do you have to fail the whole LUN over to another?
Well, no, right. So today, you have to allocate a LUN per VM, and fail over all the VMs on the LUN. Well, the VM on the LUN, right?
LUN per host.
No. Let me start again.
Each machine have to run on a different LUN.
I'll give you the full answer, right? Then we're clear. So if you're not using System Center Virtual Machine Manager, you're just using clustering, and you have the right fixes, today you can put more than one VM on a LUN if you want to, or just one VM. But when you fail that LUN over, the VM or all the VMs on it fail over at the same time. Okay? If you're using System Center Virtual Machine Manager to do your management environment, today it assumes one VM per LUN. Okay? And that's hard-coded in its logic. And the reason, the sort of the background to that is there are file systems, and one of them is Sambolic, that will allow you to have the Hyper-V hosts all sharing the same drive. You can have one big LUN, put all your VMs on there, and in clustering, you can then fail over individual machines by using, you know, a different file system. Doesn't work with System Center Virtual Machine Manager today. And the last part of this answer is, it's the only time I've spoken about futures, but it's well known, is in the next version of Hyper-V, Microsoft will have their own clustered file system. So it'll be one big LUN, and you can put all your machines on and fail them over individually. Okay? So, thank you very much. Ray wanted me to put up this so he could talk about the next event. Is he here, or has he run away?
Yeah, I was going to tell us what's happening.
Right.
That's a good one. So, cool.